survive such a thing. So what we're talking about here is convergence of these three parts that I was talking about. So we've got imaging. So you put the patient into a CT scanner, or you do an MRI scan, or some other 3D scanning mechanism. And from that you can map out the shape of the injury itself. This would happen not just for skull injuries, but any tissue injury or any tissue damage could be caused by tumour resections and things like that. Once you have a map of the injury itself, from that we can then use computer software to be able to build a three-dimensional virtual model of what we want the replacement tissue to be. And that's where a big part of our research is as well, is around this software part, to be able to develop those technologies. And then that 3D model is not just designed to fit into the defect site itself, but also have some internal structure. And in biofabrication, and when we're looking at tissue engineering, we're looking at implanting these. So these have to also then have the little biological characteristics so that they can implant well. Then that model is used to drive our 3D printers. This is a model of one of our proprietary 3D printers, and these aren't standard 3D printers, these are biofabrication machines. They work on a resolution much greater than a standard 3D printer. So we're trying to mimic the body's own structure, the own internal structures at very fine resolutions. And the materials we use too are biocompatible, dissolvable materials. They're tailored to the different requirements of the tissue itself. And then also we can then place inside of these structures that we make, these biodegradable polymers, we can place hydrogels, and the hydrogels contain the patient's own cells. They can contain growth factors and materials like that. And also, I'll talk a little bit about it a bit later, but these materials as well can also contain some organic semiconductor electronic elements as well, so we can start to incorporate some bionics into these implantable tissue constructs. So the idea is that, like with normal 3D printing that you're familiar with, it's all about a layer-by-layer production of a structure so that you build up your three-dimensional model, all driven by that computer. And just here's a bit where we can zoom in, and you can see that the structures we're working on are at that structure that mimics the body's own internal structures, and the cells attach in and can grow well within that. So that internal structure, that internal architecture is very important for us to be able to achieve as well. And then after the cells have grown inside, that can then be implanted back into the patient and can restore the tissue function. So that's sort of a vision of what biofabrication means for us as a research group anyway.